Imagine looking up at the night sky. Now imagine something looking back, not with alien eyes but with technology so powerful it could see the expression on your face. This isn't science fiction, it's the reality of modern space technology. The sky is no longer just a canvas for stars, it's a vantage point for observing our world in stunning detail. Satellites orbit silently above, helping us navigate, predict weather, and connect globally. But some satellites serve a different purpose. They are our eyes in the sky, designed to see what happens below. Over decades, these eyes have become sharper, evolving from blurry images to high-definition color. Now we're on the verge of a new leap, actively scanning Earth with lasers. The challenge is immense. Spotting a single person from space is like finding a grain of sand on a beach from an airplane. Yet, new technology promises to bridge that gap, offering microscope-like precision from orbit. This changes our relationship with space, turning the void above into an active, observing presence. The journey here is a story of human ingenuity, from spy planes to camera-equipped satellites. We've always wanted a better view, to see more, understand more, and gain an edge. Now, we're entering a chapter where focused beams of energy paint a picture of our world, one laser pulse at a time. The sky is no longer the limit, it's our new observatory. Satellites are no longer just tools, they're extensions of our senses, reaching down from the heavens. The cosmos, once a source of wonder, is now a platform for watching ourselves. This is the dawn of a new era in surveillance and understanding. The question is, what will we do with this unprecedented power? Our story begins with a satellite that's changing everything. Meet SAL, Synthetic Aperture Lidar, a Chinese satellite that's redefining what's possible in Earth observation. Reports claim SAL, orbiting over 400 kilometers above, can achieve millimeter-level resolution. That's like reading the date on a coin from hundreds of miles away. This isn't just about seeing cars, it's about reading license plates, identifying faces, and distinguishing fine details from space. SAL doesn't just take pictures, it illuminates targets with lasers, capturing reflected light to build detailed 3D images. Achieving this from orbit required overcoming huge technical hurdles, from stabilizing lasers to processing massive data streams. The implications are profound, persistent, high-resolution surveillance from a place that's nearly untouchable. Unlike drones or planes, satellites are hard to intercept and pass overhead silently. SAL represents a new paradigm, a constant, hyper-detailed stream of information about almost any point on Earth. This is more than a technological leap. It's a fundamental shift in how we see our world. The age of millimeter precision from orbit has arrived. How does SAL work its magic? It starts with LiDAR, light detection and ranging. The satellite fires laser pulses at the ground. The light bounces back and sensors measure the return time to calculate distance. By sending millions of pulses, SAL builds a 3D point cloud, a digital model of the terrain below. LiDAR works day or night, since it brings its own light source. The synthetic aperture part is the real trick. As the satellite moves, it collects data from multiple positions, simulating a much larger lens. This virtual lens allows for incredible resolution, far beyond what a physical lens could achieve in space. By stitching together these perspectives, SAL resolves details once thought impossible from orbit. It's a fusion of physics and computation, using movement and time to create clarity at breathtaking speed. The result, a 3D high-definition map of Earth, built one laser pulse at a time. This is the science behind the satellite's extraordinary vision. To appreciate SAL, compare it to other ways we observe Earth from space. Optical satellites, giant cameras in orbit, produce beautiful images but need daylight and clear skies. At night or through clouds, they're blind. Synthetic aperture radar, SR, uses radio waves, seeing through clouds and darkness but with lower resolution and less detail. SAL combines the best of both. It works day or night, and its laser's short wavelength delivers unmatched resolution. It doesn't just take pictures, it measures the world with laser precision. LiDAR provides true 3D data, not just flat images or surface textures. Each point in a LiDAR scan has exact X, Y, and Z coordinates, enabling precise digital models of cities, landscapes, or military sites. This isn't just a snapshot, it's a virtual, measurable copy of reality. SAL's technology turns the sky into a tool for mapping, measuring, and understanding our world in ways never before possible. The difference is not just in what we see, but in how deeply we can know. The world is no longer just photographed, it's scanned, measured, and reconstructed in 3D. The implications are vast. The uses for SL's technology are transformative. For militaries, it's a game changer. Imagine counting bolts on enemy equipment or identifying missile types from space. It enables technical intelligence, revealing not just what's there, but how it works. SAL can monitor critical infrastructure, track high-value individuals, and verify locations without risking human agents. In space, it can inspect satellites, diagnosing malfunctions or gathering intelligence on rivals. Civilian uses include ultra-precise mapping, urban planning, disaster response, and environmental monitoring. But with such power, surveillance will always be the primary concern. The line between security and privacy has never been thinner. SAL's vision isn't limitless. Weather is its biggest enemy. Clouds, fog, and rain can block or scatter its laser, leaving it blind. Tracking moving targets is tough. High-resolution images require stillness, so fast-moving objects blur. The data load is massive, petabytes per pass, demanding powerful processors and supercomputers to handle and analyze it. This bottleneck limits how much of Earth can be scanned and how quickly data can be used. Countermeasures are inevitable. Special coatings, smoke, or even lasers aimed back at the satellite could disrupt its view. The history of surveillance is a constant game of measure and countermeasure. SAL is powerful, but not invincible. Every new technology brings new ways to hide. The cat-and-mouse game continues, even in orbit. SAL's debut sends shockwaves through global geopolitics. The US, long dominant in space intelligence, now faces a rival with potentially superior tech. Expect a rapid response, accelerated research, secret projects, and a new race for optical supremacy. Other nations, Russia, Europe, Japan, India, will scramble to keep up, investing in their own surveillance satellites. Alliances may shift, with countries pooling resources or aligning with major powers for access to intelligence. The sky becomes a new arena for strategic maneuvering. As surveillance tools proliferate, the world grows more transparent and more tense. Hyper-detailed observation could deter aggression, but also fuel suspicion and misinterpretation. The unblinking eye in orbit is a new player on the geopolitical chessboard. The balance of power is shifting, one laser pulse at a time. SAL's implications go beyond governments. They reach into our private lives. What does privacy mean when a satellite can see your face from space? The digital age has already eroded barriers, but this is a new frontier. The idea of being watched from orbit challenges our sense of anonymity. Laws and ethics lag behind. Most privacy rules weren't written for space-based surveillance. Who controls the data? What rights do citizens have when observed from above? As technology spreads, private companies could deploy similar systems, raising the stakes for misuse. We're at a crossroads. Must we accept a world where hiding in plain sight is impossible? We stand at a turning point. Our eyes in the sky are sharper than ever. SAL is just the beginning. Future systems may overcome today's limits, using AI or new wavelengths to see through clouds and track movement. The drive for a clearer view is relentless, but it forces us to ask, how do we balance security with privacy? The same technology that ensures safety can also threaten freedom. There are no easy answers, only the need for global dialogue, new treaties, and public engagement. The cosmos has always inspired wonder. Now, it also demands responsibility. If we see the sky only as a source of anxiety, we lose something precious. The challenge is to use these tools for good, science, safety, and progress, without sacrificing our rights. This story is about us, our brilliance, our fears, and our choices. The images from space reflect not just our world, but our values. As we push the boundaries of what's possible, we must also define what's acceptable. Our future, under the watchful sky, depends on it.